there's been a little bit of a change, and you all were kind of in the middle of that changeover. Have you done matrices before? Anyone else for one? No. So a matrix is a rectangular You've never heard that word? Yes, you have. It's a movie. You've never seen the movie or heard of the movie The Matrix? Can I read you? Where they do like this? No? Okay. I haven't, but everyone's seen that part. Okay. A matrix is a rectangular arrangement of numbers. I'm going to suggest that if you checked out a calculator, you start bringing it to class tomorrow, for sure. You won't need it so much today, but tomorrow for sure. So, I'll show you. That's the matrix, right there. That's the matrix. Isn't it pretty and purple? Or pink? Maybe this is fuchsia. Like I mixed it. Anyway. Alright, so each little part is called an element. So each little part is called an element. And matrices, one is a matrix, more than one matrices, okay? Matrices have dimensions. We name their dimensions using rows, then columns. Rows by columns. That's how you name the dimensions. So this has 2 rows and 3 columns. This is a 2 by 3 matrix. Some people confuse rows and columns. Okay, when you go into the movie theater, the rows go this way. So the movie theater, the rows go this way. These rows go this way. Okay? Columns stand up in front of the building to hold them up. Columns stand up. So this has 2 rows and 3 columns. RC. That's RC colon. Rows by columns. This is a 2 by 3. Okay? 2 by 3 matrix. Those are the dimensions. And what are these things called? Elements. Okay, great. Alright, and then like each matrix element has position, like if I said A 1, 2. That's not A12. That is the first row and the second column. So the first row and the second column would be that 2 right there. That's the element A12. Okay. Pretty easy. Pretty easy. Let me give you something to try. How about what are the dimensions of this matrix? This is a 3 by 4. Okay, that's a 3 by 4. What is a 2, 3? 0. Second row, third column, and then 0 right there. You can take data, a chart, and you can put it in a matrix. Okay, so for example, and then they're mostly used for inventory. You can do all sorts of different things with them for companies, and they work really well in Excel. So you can do a lot of stuff. So let's just make up some data here, okay? So this is US Russia and Canada, I don't know, and then China. And these are gold, silver, bronze, and of course the U.S. got the most, so it's like 48. And we got 12, and we got 18, and China got 30. And then we got 10 silver, 9, 6, gold, and then bronze we got 14, and Russia did, and Canada got 38, and they got 7. Okay, so this is the table that you're looking at, and you can just very easily, if you had to do something with this data, if this is an inventory for a store, and you're having to keep up with something, now it's a matrix. So we can turn data into a matrix and sit around and do stuff with it. What can we do with it? Well, there are lots of things. I'm glad you asked what you can do with it. That's your question. Okay, here's what you can do with it. You can add, you can subtract, and you can multiply. Okay, we're going to add and subtract and do a little bit of multiplication today. Not a lot. Trust me, when we start multiplication, you're going to want that calculator. Alright, you can add matrices as long as they have matching dimensions. You can add and subtract matrices if they have the same dimensions. We name matrices capital letters. So that's matrix A, matrix B, and matrix C. A plus B. Matrix A plus matrix B. I'm going to add their corresponding elements. What corresponds with element A11? Yeah, that's 5. Right here. Yeah, exactly. So what's 1 plus 5? Okay. What's that 2 going to be added to? Okay, which is 21. 4 and 22, right? What's this going to be added to? Yep, 10. And right here? And right here? Exactly. You see how hard that is? That's really tough. That 26 and 21, those are tough because you ran out of fingers on that one. Right? That's A plus B. Guess what you do for A minus B? You subtract corresponding elements. Yes. Okay, so let's try that one. There's going to be some negatives involved. 1 minus 5. Okay. 2 minus 19. That is correct. 4 minus 22. Yeah, I don't know what that one got. Okay, 3 minus 7. Negative 6 minus 3. Or negative 9. Yeah. 5 minus negative 14.
Negative 14.
5 minus negative 14. It's not going to be negative. 19. Yeah. Okay. Now how about this one? A plus C. There, you can't do that. Why can't you do that?
They're not the same dimension.
Right, they don't have matching dimensions, so you can't do that. It's not possible. It's not possible. They have to have matching dimensions, okay? Some things about matrices. Matrix addition is commutative. It doesn't matter what order. If I add A plus B or B plus A, I'm going to get the same answer. Matrix subtraction, like regular subtraction, not commutative. A minus B is not the same as B minus A. But that's real subtraction too. So, like 4 minus 7 is not the same as 7 minus 4. Okay? This is called a square matrix. Guess why? It's square. Yeah, when you have the same dimensions, the same number of rows and columns, those are square matrices. They're going to be important a little bit later on. Okay? But that is called a square matrix. Let's see. There's a zero matrix, and it's just a matrix filled with zeros. What is that? I don't know. Let's do an equation. It's really not that bad. There are a couple ways that you can look at a matrix equation. I could say what would x have to equal? If I added matrix x to this and got that, what would x have to equal? How can you figure that out? Just subtract. Yeah, subtract these two matrices. Just like regular algebra. Just subtract. What would x equal? 2, where did the 7 go? Okay. Excellent. That's what that has to equal. Okay. Another way that you could look at got it? Another way that you could look at a matrix equation is if you have equal matrices, and if the two matrices are equal, then their elements are equal. So let's say you've got like 2x plus 6, 12, 9x, and I don't know, 15 equals 18. Wait, I think we should probably change variables. Those should not all be x's in the same problem. Okay.
First part was easy. This one.
Yes, no. 2x plus 6, the elements are equal. 2x plus 6 equals 18. I'm going to change these. I'm going to make that a y. I'm going to make this a w. I'm going to make that a z. There you go. So that will be confusing if all four answers are x equals this and x equals that and x equals that. That's confusing. How do I solve this? It's a two-step equation. How do I solve this? Subtract 6. Thank you for saving the entire class. So that's 12. And then what happens? Divide by 2. X is 6. Now let's solve for y. What is 9y equal?
42.
42. And let's solve that.
42.
Divide by 9. Do not give me a decimal answer. What is y equal? What is that?
42.
I don't think it's 16, is it? 14.
11.
What does 12 equal? So we would add 7. And 19 is W. And then what does 15 equal? Yeah, that ugly Z. Let's see. So I'm going to subtract 8. 2 minus 8. So 7 and Z. That's not bad, is it?